Good morning, students. In this lecture, we are going to solve a problem in the design of logic circuits. The problem is draw the logic diagram and the timing diagram of modulo 12 asynchronous counter. Indicate at least 4 clock cycle in the timing diagram. Right. Now here, how do you design? We'll see that one. So here, this is asynchronous clock cycle. So asynchronous counter, modulo 12 asynchronous counter. Right. Now here, we'll see that one asynchronous counter. Okay, here this is actually we are having using T flip flop. Then if you are having this connection with asynchronous, then first clock is connected with directly the clock, and the second one is the output of the first T flip flop and is connected with the clock. Then here is second one connected with clock, third one is connected with clock. Right, right. Then here we are having this reset button. So reset pin. Reset pin is when that value is 0, then it will make all flip flop as 0, right? So now here we are having now that initially you are having 0 0 0. Initially we are having 0 0. Now we apply that value here. This is VCC is 1. So that 1 is here, then it's toggling. So this is already 0. 0 is converted into 1. So this is the toggling. 0 converted into 1. Then here we are having next in the next pulse. The next pulse is the 1 is converted into 0. So 1 to 0, that is negative edge. Then it will make this as 1. So this is 0, this is 1, and these are all no change. This is going on, right? So to second one. So this is the transition. Then the next clock cycle, right? Next clock cycle we are having now. This will make us a 1. Then here we are having that one. Here one make us 0. One the toggle is 0. 1 to 0. Then we are having next one is we make a toggle. This is 1. This is 1 and 0 0. 1 1 0 0. So this one, right? Then we are having now the next clock pulse. This 1 1, right? So that is 1. 1 is converted into 0. So that's negative. Then it will make this also make 0. Then already we are having this is 1. Because of that 1, it will make us 1. 1 0. So that is here the fourth one. And so on, it will continue the binary number, right? So this is a binary number, next binary number, and so on. It's continuing now. Then at the time of 12 reaching, so this is we are having 1 1. This 1 1 is making that inverted 1 1. So that is here, these two are 0 0. This 200, then previously everything is here, this the end is non-zero, right? So that is any one of that input is 1, then this is making is 0, right? So here we are having this is all are making 1. Making 1 is not resetting. Then here both are 0, so that 0 0 is reaching now here. If this is the Q4 and Q3 is 1 1, then this will reach as 0 0, right? So this will reach as 0 0. This will reach as 0 0. So that one is here. Not QA. So this will reach as 0 0. 1 1. Then this will reach as 0 0. That one is right. So this is the Q3 and Q4. So the here Q3 and Q4 is these two. So these two here not. Actually, this is not the diagram. So here Q3 and Q4 is connected, right? So that one is here. Right. right? So this one is here QA, QB, right? So this is Q4 is A, B, C, D, right? So that A, B both are 1 as the A bar, B bar is 0, 0. So that 0, 0 is reaching at the time of this status. All other cases, any one of that input is 1, right? So 1 is here, any one of that input 1 in the OR gate, the result is 1, then it won't reset. Whenever both are 0, then it will reset. So this is reaching now at 12. This is we are having now the reset. Reset is going to have us make is 1, 0. The 0 is making that one all. So that one after 12 it will reach now. At the time of 12 it will reach to. So if that the situation, then it will convert it into all are 0, 0, 0. So it will make the conversion of 0, 0 because of the reset. So instead of that status, the state is going to have us 0, 0. Then it will continue the loop, right? Now the timing diagram we have to draw. Timing diagram. So clock pulse, at least 4 clock cycle, right? So this is a clock cycle. 4 clock cycle, 1, 2, 3, up to now 14. This is a negative logic. Because of this one as you consider now this is a negative logic. Then in that negative going edge, then it will have that one, right? So initially the negative going edge, then the D flip flop is going to have us 1. It will make us 1. So this is the first step. 1, then 0, 0, right? So this is 0, 0, 0, 1. Then 0, 0, 1, 0. So here in that negative logic, then it will convert it into 1, right? So this 1 is continuing now. Our next negative logic of this clock. So this is the clock to the next one. Then this is the clock to next one. Then this is the clock to next one, right? In that location, we are resetting. Reset, right? So that is here, right? So that is in that negative edge. Then we have to draw the high in change toggle. Then here in that negative edge, then once again the toggle, right? Then here the negative edge once again toggle. So the bottommost we are having now that using the clock, right? So in that negative edge we are having transition. In that negative edge we are having transition. So in that negative edge we are having transition. In that negative edge, right? So this is the negative edge. So sorry, this is not positive. This is the negative edge, right? So it's a negative edge. Then this is the negative edge you are having transition. Negative edge we are having transition, right? Like that the low first flip flop is in transit for all negative clock pulse. So this is the clock pulse of the first flip flop, right? First flip flop means here we are having now. This is the case D flip flop. So D flip flop toggle each and every negative edge. Each and every negative edge toggle 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. Then here we are having now whenever that we are having the transit to 0 to 1, 1 to 0. This is negative logic. So in that negative logic, we are having transition. Now this is a negative logic, we are having transition. This is a negative logic, we are having a transition. Right? Then here we are having in that negative logic, we are having a transition. In that negative logic, we are having transition. And so on, you have to draw. In that negative logic, we are having transition. In that negative logic, we are having transition. Right? Then here, this is the negative logic. So higher to lower. At that time, we are having transition. Next, this is a lower to higher, there is no transition. Then higher to lower, we are having a transition. Right? Higher to lower, we are having a transition. Higher to lower, right? So this is the higher to lower, we are having a transition. But this will make the transit as a 1. This will make us a transit as a 1. But at the time, then we are resetting. So we are resetting now. Then it will make the 12th cycle is going to be reset by this circuit. So it is making the resetting of that circuit. And then we are making this as 0, right? So here we are having this a negative logic. In that negative logic only we are having that first, right? So now this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 0. 0 next to 1, then and so on, 2, 3, like, right? So this is the way of implementing the asynchronous counter using T flip flop. Then we are drawing the timing diagram, right? So this is a logic diagram. This is a table. Then this is a logic diagram. And then this one is using the timing diagram. So timing diagram, you have to show that one. So this is the way of drawing a timing diagram for the counter. We can stop here. We will continue by next.